Hi, I'm Michael O'Neill. I'm here with Dean Nelson,
Hi.
VP Global Foundation Services at eBay. Thank
Yes.
you for joining us. So here in the data center power and cooling environment, you're kind of like a rock star because you're
I don't know
on the
about
hall,
that.
you get interrupted all over the place.
People just want our money, that's all.
But they also want to learn from the big Project Mercury that you've done. And,
Yeah, it's worked out pretty good.
yeah, and I was hoping I could walk you through that a little bit and have
Yeah.
you explain, what it is that you've done, what it is that you've learned, and
Sure.
maybe start with your approach to hardware and to costing hardware and to
Yeah.
how you do that. And,
Well, let me start with just my job. So, and I'll tell
Thanks.
the people who are watching
Okay.
here too. So I run data centers, networking, and global supply chain. So if you think about it, it's everything from forecast to the actual retirement of the equipment.
Mm-hmm.
So my team does pay the power bill, and we also select the hardware.
Mm-hmm.
So it's both sides of the decimal when you think of PUE. We affect both. And we're on the profit side of the business, which is very interesting because we report up through the CTO. And if you think of the engine that is underneath running eBay.com, that's what we run. So the foundation, that's why Global Foundation Services, we provide all the services that enable 100 million active users all over the world to be able to access 300 million items for sale at any given second. Right, it's those kind of numbers. There's significant transactions.
very large numbers.
It's the world's largest online marketplace. So Project Mercury really was to answer the demand from what was going on in the industry. So we've got rapid growth. I mean, 300 million active listings has come from 160 million when I joined the company 2.5 years ago. But all of that demand, whether it's mobile or online, they're all buying more. And they're all getting educated. So our users are going to find what they want, wherever they are, however they want to get it, and then however they want to buy it. And what that translates into is more compute capacity, more network capacity, more storage capacity, and ultimately, where do you house and run this?
Right.
And so my job is to run the team that builds that engine underneath. So think of infrastructure as a service,
Okay.
right? So from where you're going to take an order and turn it into cash equipment, meaning the equipment that's ready to be turned into function. So infrastructure as a service goes to that level. So that's what our team basically is operating. And what we did with Project Mercury was answer two things. First, the new demand that was coming. And then we also had over half of our equipment had to be replaced this year. So
Really?
this last year, yeah. And those two pieces added up to the largest hardware purchase we've ever had in the history of our company in a single year.
And yet, when you look at hardware, you don't just look at the depreciated cost of the hardware or the shell around it. You also look at the use of power in there as well.
And Project Mercury really was about, we did this case study with the Green Grid. So we're sharing the learnings. And I'll cut to the chase. The real big elements for it were really three. So it's the alignment facilities in IT, so paying the power bill and selecting the hardware, optimization of that, using PUE as a design driver, not as an afterthought. And then the third one is TCO, so total cost of ownership as a decision maker. And that goes back into what you were saying. So those three elements are really what gave us some incredible results out of Project Mercury.
So I was going to end with the organizational alignment, but since you brought it up, why don't we start there? It's very unusual to have the person responsible for the power, including the decisions to make that equipment power efficient, also have the power bill attached to that. How long have you been doing that?
So they've been doing that since I came, right? And it was one of the things that attracted me is having all those folks under the same team. I know you can get a lot done, because you don't have this infighting. You have to come together and you have to go after the same goal.
Well, and you would also have the benefit of, if you make an investment in an energy efficient technology, reaping the benefit of that within your budget rather than watching that leak out into another budget.
And usually it's two different budgets that are competing, right? And they don't want density, they want density. They just want to buy hardware, they want it to land, and it's always a big challenge. But the great part is, and I like to lead with the alignment because without it, we couldn't get the efficiencies we got.
Right.
It's just really, really difficult to try and force people into the direction you want, right? By having them all on the same table, then you can really have a conversation that says, look, if you bought the server this way, then we could optimize the data center that way. We could give you more density, more capacity, and higher efficiency. And just those conversations are great. So that's the alignment piece, but then you look at the PUE as a decision driver. They need to know what's happening with the hardware. And so a couple things that happened with us is we took all of the hardware we had, we inventoried it, and found we had almost 200 different server SKUs. Okay? Over 300 all SKUs.
Okay.
That's hardware configuration. And so we then looked at those 200 and found that there were 15 that made up 80% of the hardware we purchased. So we addressed those 15.
Okay.
We consolidated those 15 down to 2. So by consolidating those 2, if you think about that, we have all of our applications for high-performance computing, whether it's search or back-end or all those things, all fit on the same hardware. Great. Then we have, so that's high-performance compute SKU. Second SKU is big data, which had to have a lot more local storage.
Okay.
So those 2, then we can start to optimize packaging. That's where we had rack and roll and containers now because of volume. Then we could build and optimize the supply chain because we had all that technology refresh we needed to do, as well as the new stuff. They're all going on the standard hardware. Then we could start to rapidly deploy out this thing to keep up with the demand.
So you deploy those 2 SKUs either inside your structure or through containers? So you
Yep. And really we had, the data center is set up with 7,400 square feet on the ground floor, very small, and 7,400 on the roof. But those 2 add up to 12 megawatts of IT capacity in 14,800 square feet. So that's up to 40 kilowatts of cabinet. So you think of technology refresh over time that allows us to we could do 4 or 5 tech refreshes depending on what it is we're refreshing.
So 40 kilowatts a cabinet would be at least 3 times what you see deployed in kind of
the average today is still 8 kilowatts. Okay. The average in Asia is 4 kilowatts, right?
And the people who are looking for dense configurations still don't tend to get much beyond 12 or 15.
And that's because of the IT and facilities misalignment. If you look at it, colos, they have to deal with all the different mixed of vendors, and IT folks, they care about IT.
Right.
I just need a place to land my stuff. I don't care if it's not fully racked up. I don't care if it's not dense, right? Now when you start to bring all these people together and look at the whole story, it's interesting because they can see, I can turn that knob, I can get more capacity. I turn this knob, I can lower the costs. But we're all reporting to the CTO, right? We're all out there to try and get more listings and have more people use the site and more mobile users jump on. It's just, so it all starts to link. So that PUE is a design thing, works out well. And then, of course, TCO is the decision maker.
Or PUE is a decision maker. Right?
PUE is actually the design driver. Okay. So how we design, we're saying, and we told the people that won the RFP for this bid that you're going to guarantee 1.2. And so 1.2 PUE at 80% load over time, right? Okay. You're going to guarantee we're going to perform at that level, or else they have financial penalties. So that's the design driver. It's not an afterthought with PUE to measure it then. It's about what you do at the beginning. And then when you have the design teams, as well as the construction teams, as well as the operation team, the ones that are going to take the keys from them when they're done, all at the table from the beginning, all of a sudden you know how it's going to play out.
So when you say the people who won that bid, they would be furnishing not only compute equipment, but the cooling and power distribution equipment around it?
No, so what you have is the guys...
So how do they guarantee the PUE then?
They design the data center, right? Because PUE it doesn't care about the IT. If you look at it, PUE is, the one is constant.
Okay.
The point something
that's right.
is the facility, right? So what we've done is now address the left side of the decimal as well.
Okay.
We're looking at both sides so that we can optimize the total.
So you move down the one with efficient hardware and then work on the other side of the decimal.
The amount of compute needed to do the work and then the actual efficiency of deploying that compute.
So and on the efficiency score, some of the, coming from Canada, we think about free cooling as being a function of having cold winters.
Natural, right? Yeah.
Yes, and you're talking about free cooling up to 120 degrees Fahrenheit.
Yes.
How do you do that?
Well, that's part of the design. So that's where, and let me finish on the TCO first,
okay,
right?
Sure.
Because it ties into it.
Okay.
We took another RFP and said we are going to pick our solution providers for IT equipment based on the unit cost and based on the wattage consumed of the devices over its useful life with our workload, which means we know the full cost.
Right.
That's including the PUE components of it. And so whoever comes back with the lowest total cost of ownership will win the bid. And that's exactly what happened.
So do you factor in the heat generated as part of that?
So what we told them is you will get free cooling year-round in Arizona. That means that had to be part of the solution, and they still had to have the lowest wattage with the maximum amount of transactions, basically.
Right.
And so the ones that came back with that answer, we had modular solutions that went on the roof. We also had rack and roll in the ground floor. And that worked out great.
Do you use the same hardware configs in both places?
We have the same standard SKU with different manufacturers, with different packaging that deliver the same results. because I don't care.
Either wrapped inside a container, plonked on your rooftop,
or a rack going on the ground floor. Yeah, and so we can get the same benefits from it. So that TCO is a decision maker, right? Or is a decision maker, yes. And then we use that data center maturity model actually to map how well we did across all of that from the green grid.
Yes.
But the results of it ultimately were that the container we measured, so we measured the Dell one up on the roof, and that was the 119 Fahrenheit on that day. It was August 23rd, 2011, I remember, because we're up on the roof measuring these temps, and it was insanely hot, right?
And if my notes are correct, you were at 1.044 at that instant.
So there were 3 measurements. So we ran the container at idle, and it was 1.04.
Right.
And then we went and ran it at max load, which was at 550 kilowatts, and it was 1.044. Now that's partial PUE. Okay, so that's for the container itself.
Right.
But even if you start to take everything upstream from it, it's less than 1.1 on the hottest day of the year in Arizona. So we're getting free cooling.
How do you cool some? Again, coming from Canada, we equate cooling with snow and stuff. How do you do this?
Part of the design we did was there's really 2 elements you have to look at. The outside air temperature actuals, that's going to be the water, okay, in a tower. Okay, and then the actual chip of the chip temperature. If you design to those 2 elements, and what we found was the outside air temperature, even at 119 Fahrenheit, with adiabatic, is 87 Fahrenheit maximum. So just think of it, you got this dry air coming in very hot, and you have a little rain coming through it, and it extracts the heat.
Okay.
And the maximum temperature coming into the front of the servers is 87 Fahrenheit.
Okay, which is inside the...
Right. And so that's what the inlet temperature is. That's well within the specs of everything.
That's within the ASHRAE specs, right.
Then you start to look at, well, if I have tower water, that the maximum temperature the tower water would ever reach is 87, well, then I could deliver 87 to the in-row conditioners and the other things, and could you get free cooling around that? And we've achieved that as well. Now you have a rise from the chilled water to what goes inside of the center, but we're still able to get free cooling year-round. But the most impressive part is taking a container, landing on the roof, exposed to the sun with 1,920 servers, 550 kilowatts worth of load, max load on it, and it's getting free cooling and a PUE of 1.044. It exceeded my expectations.
And not just yours. Go back to the Green Grid guidelines from 2007. They thought 1.6 was as good as the Sudan.
And the average is still 1.8, right? I think in the industry today. But now if we look at the overall site PUE, so on the day in January that we measured this, the site PUE was worst case 1.5, or 1.35, sorry.
Right.
And then best case was 1.26.
Yes.
But that's a 35% load of 4 megawatts. 35% load on the site. What we guaranteed was 1.2 at 80% load.
Right.
We're at 1.26. You know why?
Because of the inefficiency of the power distribution and cooling.
No, that dropped down to 1.26 because the ground floor still wasn't full and you have different wastes and things that are in there. The containers dropped the entire site PUE. The performance of the containers actually lowered the overall PUE. Without it, it would be up in the 1.5, 1.6 until you start getting to the 80% load. Which means every container I land in the center makes my entire data center more efficient.
So do you fill up the roof then before you start rolling into
So
the
we're
floor?
already deploying more containers in there because they're just so friggin' efficient. I mean, it's just, you think about it, that exceeded my expectations because I was expecting is we'll get efficiency across the board. But here we got an even more efficient box, right? Because the IT manufacturers and the facility components around them all tuned into one big rack deployed and plugged into something in our center. Bang.
So why can't you replicate that same kind of efficiency inside the data center itself?
You can. You can. And we've done that from a containment standpoint, but still you got 4,000 amp busway and a lot of losses throughout all of it. We've got in-row conditioners. We're still getting good efficiency, but you still are building these big chillers and towers and lots of pumps and everything else to do what the max load at the end state would be. If you look at a container doing adiabatic with city water, the only thing it's using is upstream transformer losses and then generators and UPS.
Right.
But when you look at a pumping water around there, you have the pumps and you get the loaded cost of the pumps all the way across and all that. So, but the key is that there's a hybrid approach here that allows you to do modular, hyperscale type, container deployments and high density rack and roll type deployments in the same center. And you can get to these incredible efficiencies. And I still spent half the CapEx to do it. And it's half the OpEx in that center for that one than it is versus my current one. You can't fight the actual business results from actually aligning facilities in IT. that's what you get.
And you're starting to push down that crossover curve, right? You mentioned before we started in terms of where the OpEx and CapEx cross over. Because
Right.
you can be
Yeah, the cost of the
efficient
server and yeah.
if you can be efficient on both sides, you push the entire group.
Right, because we ended up spending a little bit more for the servers, yet we bought less of them, and we're using less wattage. So,
That's great. Last question. Do you have any words of advice or words of wisdom that you'd like to share with the folks who get to watch this?
collaborate. Collaborate. Go out and listen to your peers, right? Find out what's going on because you always gain nuggets out of those conversations.
And then make sure you align the organization.
Yes.
Yes.
Yes, absolutely.
Thanks.
Great.
That's
Thank you very
terrific.
much.